All right, in this video we're going to look at how do we analyze graphs of functions and relations. So our very first topic is estimating function values. We do this two different ways. From a graph, we're just going to look at a graph, and then algebraically we'll plug in the values that were for the variable given. So here we have a graph of f of x equals x squared minus 4x minus 5. And we're going to estimate f of 1. So that's just an x value of 1. Well, if I were to estimate that, I'd go to x is 1, and then I'd just go down here on the graph, and I'd see that that is negative 6, 7, 8. So my guess from the graph is that f of 1 equals negative 8. So let's verify that algebraically. F of 1, we're just going to replace all the values with 1, and we'll end up in the same position. F of 1 equals negative 8. So that's just estimating function values. All right, another topic that we can review is domain and range from a graph. Remember, domain are the x values that we read from left to right, range, y values from bottom to top. So our domain, this point is included, so our domain starts with the x of negative 5. It's included, so we put a bracket. And then as we make our way across, we see that this hole here doesn't include negative 2. So whenever I get to negative 2, I'm going to have to use a parentheses in union from negative 2 on, and then this arrow indicates that it goes on forever. So on to infinity. Of course, that's an interval notation. If I wanted to write this in set builder, the domain would be the set of x's such that all of these x's are greater than or equal to negative 5, and x cannot be equal to negative 2. With x as an element in the reals. All right, the range we just read from bottom to top. So the lowest y value is negative 4. It is also included. And as we go up, we can include this in the range because it's included over here. So the range actually just goes from negative 4 on to infinity. Set builder is a little bit different because these represent the y's. So it's all the y's such that y is greater than or equal to negative 4 y, an element of the real numbers. Again, very sorry for how my sets look on this iPad. All right, some more review. Finding y-intercepts. Since x equals 0 at a y-intercept, just find f of 0. Plug in 0 for all these x values. You can go ahead and pause the video and try that yourself. So replacing with 0, we end up at 4/3 or just 1 1/3. So this will have a y-intercept at 1 1/3. So if y-intercepts, you plug in 0 for x, what do you think you do for x-intercepts? For x-intercepts, you plug in 0 for y. Other words, zeros, roots, solutions, all the same thing. So here, this can be a little bit trickier. If we say 0 equals 2x squared plus x minus 15, well, the only way that we're going to solve this one, besides the quadratic formula, is seeing if we can factor it. And because this isn't a factoring lesson, we'll just go ahead and show that the factors of this are 2x minus 5 and x plus 3. And now all we have to do is just set each of these factors equal to 0 and solve. So I've got each of them set equal to 0. Add 5 to both sides, I get 2x equals 5, so x equals 5 over 2, and x equals negative 3 are the x-intercepts. All right, so that's all review. Time for some new stuff. Tests for symmetry, which actually isn't that much of a new thing since you've probably seen this in geometry. Take a second and write all this stuff down. So pause the video and then turn it back on and we'll talk about it. All right, so our main points here. X-axis symmetry, you'll have xy and x negative y. And so here, if we replace y with a negative y in our equation, we'll get the same equation. Y-axis symmetry, x and negative x are both there. Origin symmetry, negative x, negative y, and x, y. And I don't know why that bar wasn't there for a little bit, but anyways, let's run some tests, and I'll show you what I'm talking about. Right here we have x minus y squared equals 1. Right? And we can even see from points here, like 5, 2 is here, and 5, negative 2 is here. So with the equation, I should be able to replace y with negative y and get the same thing. So let's see, x minus, I'm going to replace the y with negative y squared equals 1. Well, negative y squared is just y squared. And it yielded the exact same equation. So we know that this does in fact have x-axis symmetry. So yeah, it really does help like looking at the graphs of these first. All right, something that we're going to focus on even more than the symmetry is even and odd functions. First, even functions. Even functions have y-axis symmetry. Do you remember from the other page with y-axis symmetry, if you replace x with negative x, you get the same equation? Well, the fancy way of saying that is for every x in the domain of f, f of negative x gives me f of x. So if you replace all of your x's in the equation with a negative x, you'll get back f of x. Now, odd functions have origin symmetry. And if you replace all of the x's with negative x's, you get back a completely changed equation. You get negative f of x. So every single sign will change. If it's neither, either just some of the signs change, or it's not y-axis symmetry or origin symmetry. Okay, so watch out for neither as well. All right, let's identify even and odd functions. Here we have something that's very obviously y-axis symmetry, so this must be an even function. Okay, now in the second example, we don't really know because we can't see the picture of it, so we're going to replace all of these x's with negative x. All right, after doing that, we see that f of negative x yields, negative x cubed is negative x cubed, and negative 2 times negative x is positive 2x. And as you see, every sign changed. This was positive, negative, negative, positive. This must be an odd function. All right, and that wraps it up for analyzing graphs of relations and functions. Goodbye.